Welcome to the Latent Innovation podcast. I am Valérie Thijs, and in this series I speak with forward-thinking entrepreneurs and discover how innovation and sustainability play a key role in their businesses and the impact it has on society and the world. My guest today is Wiljan Cools. He is the co-founder of Nanny ML. Welcome, Wiljan.
Hello, Valerie.
So tell me a little bit more about your company, because I read in your bio that after a few years of AI consultancy, you decided to create a product. You didn't want to get stuck into the consultancy business. You are a Leuven-based startup. You monitor performances of algorithms. Now, what should they do? Do they do it correctly? Is what they predict correct? So explain a little bit to us. What does NannyML do?
Okay, so we're an ML monitoring company. So what we do is we monitor artificial intelligence algorithms, and that's also what our name stands for. It's Nanny ML, and we babysit these machine learning models after they've been researched and they've been operationalized into production, and they're actually making decisions on real world data. And the whole idea is that these algorithms, because they're trained on historical data, but the world is dynamic and constantly changing, customer behavior changes, the data changes, and then these algorithms that have been trained on data from the past, they start making mistakes. And that's where we come in, and we obsess over the performance of the algorithm. So we make sure that they keep making the right decisions and that the revenue and the according value that those algorithms bring, that stays up to par. And how we came about deciding to build this product, because you mentioned consulting. When we rolled into consulting actually a few years ago, it was really with the idea of we're gonna go and find a product or a problem that is worth solving. And as soon as we do, we go and build it, because we always wanted to have a big impact, me and my other two co-founders. And we're indeed, yes, incorporated in Leuven, but I'm Belgian and I live in Belgium, and there's an American co-founder who's a dual nationality and he has Belgium. And then there's always also a Polish co-founder and he lives in Portugal. And we're 11 people and we're in 8 countries, so we're really international. But it is in Belgium that it all started when we were studying, and that we were like hanging out in the data science community, and that's where we met.
Yeah. Tell me, how does it work to have like people all over the world, scattered all over the world, working on this technology and on the product that you are making and building? What kind of framework do you use?
To organize the work?
Yes.
So actually we follow a specific methodology for it, which is called ShapeUp, and it's based on a project management methodology that Basecamp came up with. And the whole idea is, because we're fully remote and we don't get to see each other that often, is that we organize our work in 8 weeks, and then it's 6 weeks of building and 2 weeks of downtime. And during those downtime weeks, the engineers, the data scientists, everybody can work on whatever they want or what they think is very important. And during those other 6 weeks, we create shapes and we define a problem, and those shapes get done end to end and prioritized. And then at the beginning of an 8-week cycle, we meet all together in person. And how we do that is we rent an Airbnb for a few days. We make food and we sit all together and we plan basically out what we will be doing the next cycle. And what this methodology allows us to do is, first of all, work remotely. And that so all of our engineers, they are very senior, they have families, and they can really then organize their work around their family and still have high output. And another thing what that allows us, and that is very, very important for research, is because we have these 6 weeks and these 2 weeks of downtime, every time there pops something up that is a new idea or something very innovative, we can say, great idea, but let's do it in downtime. And that way we can still maintain a great amount of focus and actually deliver the things that we set out to build.
Wow, this is amazing. Now tell me a little bit more about the process. How does it work? How do you monitor performance?
That's a great question. Maybe I'll give a small example what is easy to understand of what an algorithm does. Maybe you can take like a supermarket where there's a cashier, and when she puts vegetables in a scale, there is a computer vision algorithm that detects which type of vegetable it is. And then you don't have to put in the codes, and then we can make things faster, and it's a little bit optimized. That type of algorithm that is first trained on historical information about which vegetables, images of vegetables basically.
How they look, for instance.
Exactly.
Yes.
And then there is a sort of holdout data that we have, which is data that the algorithm doesn't see. And then we use that holdout data, doesn't see during training. And then we use that holdout data to get an idea of how the algorithm will perform in the real world. But of course, we can only really know what the real world performance is when the algorithm is incorporated in the actual system, and when it's making the pictures. And what can go wrong there, for instance, is how the algorithm is being used and the processes that follow after. And for instance, when we have this holdout performance, we have an idea or a benchmark of this is what the performance should be in the real world. But then how people start using it might actually impact it. And an example that I've heard recently is, for instance, that when the algorithm was deployed, it started predicting double the amount of carrots. And the reason being is because the cashiers, as they are starting to trust the algorithm more, they try to do their things faster. So they drop the carrots, and then their fingers are in the frame, and it's the fingers being predicted like carrots. Okay. And it's these type of things that then make that the algorithms don't have the accuracy that they were set out to have. And that is what then makes that this use case might not be as performant over time, and that we lose trust in our AI systems, and that it also doesn't bring the value that it's set out to be.
Okay, you're pointing out something very interesting. So fingers look like carrots for the AI. I want to come to facial recognition, of course, because when I go to facial recognition, in the beginning, it didn't recognize me because I'm colored, of course. It was based on historical data, of course. Are you addressing that problem yet, or do you predict, or do you want to address it in the future? How do you manage to do that?
That's a very good question. We mainly obsess over the performance and whether it's being accurate. Okay. But part of the performance, and specifically for certain algorithms, whether an algorithm is fair and whether an algorithm is unbiased, can be also considered as part of the performance. And then that is something that we also track over time, because it might be when you train your facial recognition algorithm that, because it's mostly trained on European citizens, that when you deploy it somewhere else and there's people of other origin, that indeed these algorithms start making mistakes, and then it's not just the performance, but also the fairness and the bias that creeps in. Okay. But I would say that for us is a secondary problem, and that we mainly focus on the actual performance. And I would also add there to it that I think that this problem that we're trying to solve is really after a machine learning model has been operationalized. And there's lots of problems with machine learning models that can be solved while they're being built. And this area is also very accessible to universities. And the area that we're tackling, not necessarily, because to have data from a system that is really operational, that data is not public, it's hidden, it's within companies, and then it is not accessible to academici. So I see this as a problem, also explainable AI and the bias and unfairness as something that will be solved by academia. And then we will help make sure that the algorithms are not unbiased and that they are unbiased and that they are fair. But developing the technology around it, we see that as the university problem. However, how I would see that this goal goes into the future is I think it's very important that data scientists, specifically ourselves, who build these algorithms, and that is also something that we care very much about at NannyML, that we ourselves are also trained and understand about which biases might be in the data, so that we, at least when we build these systems, can take these into account. And then as the world becomes less and less unbiased and more fair, then that will also reflect in the data. And then I think it's very important that we have processes and methodologies to retrain our algorithms on the new and more fairer data. And then I think over time, it's hopefully something that can get weeded out, but it will take time.
Hopefully not too long.
Not too long, yes.
Now tell us a little bit more about how often do you have to I don't know, retrain the software and the algorithms? How often does that happen? Because I can imagine you find one problem, for instance, a supermarket with the fingers, that's one problem.
Yep.
But there might be a problem the next day as well, something completely different, which you hadn't thought of. So,
yeah, that's a great question. And actually, it's one of these things that we can really solve with our software, is because when we track the performance and the performance is going down, we can send an automated trigger to resolve it. Okay. Depending on what the underlying issues is, which is part of a root cause analysis, we can then say, okay, now we need retraining, or now we need to take this use case down, refactor it, or we need to fall back on a different AI system, and that's how we kind of guarantee that flow. And I think this is one of these things that is often been ignored in the past, because retraining, it is really something that when you spin up retraining, it's again lots of compute, lots of resources that are being used to keep your AI systems up to date. And everybody, or at least the cloud providers, they're very much incentivized that systems are being retrained all the time. So that there's lots of money and lots of compute flowing into that direction. And this is really something of most recent years where we just almost retrain blindly, because that, if you look at the AI systems 10 or 15 years ago, that used to not be the case. And that retraining was really something that was done way more meticulously. And we hope that with our software, we can bring that as well to the market.
When I hear update, I think, oh my God, it's going to take like hours and hours of updating. Now, I think it's also a mindset change, because we used to buy software, or businesses used to buy software, and then they use it for like 10 years, and then it's written off, and then they buy something new. So how do you think we can change that mindset? Because that's something very new.
Yeah, I think actually, if you look at how also enterprise sales and enterprise deal were being done before, I think it was very much driven by the salespeople themselves, and now I feel it's way more driven about the product themselves, and there is subscriptions and subscription-based products, and I think it is inherently part of how we bring AI and machine learning models to market, that this is being implied, that we will have to always keep sending it new data so that it can get updated and that it can stay as performant as possible.
Yeah. Now, what are the pitfalls and challenges you face with your company?
So we're very early stage. And we, as the founders, we also have, for being a deep technology company, we have like an unconventional background in the sense that we came from industry. One of the co-founders, Wojtek, he started a PhD, but he dropped out. So we don't really have a very strong research backbone. Yes, and we're actually doing very innovative research. And I think that comes with then two things. First of all, that we had a cold start, that we really started tackling this problem from the moment that we did our first round of fundraising. And typically, I feel that companies that are doing similar things like us, they come from the academic world and they've already been working 2 or 3 years on their algorithms. So that makes that where we are with the technology that we have, even though it is very, very impressive of what we did in the short time, it doesn't fit into the current mental model of investors. And then there's also the entire hype about MLOps, the entire hype about generative AI. And for us, we're really solving a fundamental problem for all AI, and it's very hard to communicate these things to investors. So I would for sure say that it is getting the amount of capital that we need to solve this problem right now. But then, of course, since we're also a startup, it's finding product market fit and finding and building the product actually that people want. And I think as soon as we've succeeded at that, all of these problems will automatically also disappear.
So you're a startup, you talk about money, you talk about investors. So could you give an advice if you start a business company, even it's tech, or let's talk about tech, how do you convince people to invest in your company? Because you can tell them anything.
Yeah, that's true. I think FOMO. I think like that is the fear of missing out, I think that investors have. I think that is what drives them to make decisions. And then I think there's lots of things that feed into that. And I think it's presenting the case in such a way that it is very easy for investors to see that they're potentially missing out at something. What does that mean? Having great mentors, having already built a great company, knowing your co-founders deeply and having already been collaborating with them, having lots of lighthouse customers already, maybe having already an MVP. All of these things that hint at that there is potential success there. And I think that is and then for actually receiving or succeeding at fundraising, I think it's also a little bit of luck that all of these things align and that you hit the market at the right moment, because the market itself and how capital gets deployed, that is also very cyclical. And I think specifically for European investors, the signal of another investor being interested is often one of the biggest signals that they can act on. So I also think when it comes to for specifically first funding, I think having some business angels or some industry experts that deeply understand what you're building and for them to be convinced in your team and your technology, I think that then is the first step.
Okay, right. Now, there are some risks and potential dangers associated with AI. When you talk to consumers and the general public, they are afraid of it. We had ChatGPT, and then everybody says, oh my God, my business will disappear in a few years. I even had a presentation, they recorded me in French and they translated it in 5 minutes. It was me. No. The mimic was completely correct, the words were correct, and it even sounded like me. So especially in areas like surveillance and privacy, can those risks be mitigated?
The risk of people losing their jobs, or the risks associated with...
Associated with AI.
Yeah, so actually that is our bread and butter, because if you look at an AI system, when you leave it making decisions into the wild, it will most likely fail. And for instance, if we look at surveillance, it's the typical thing where which is called adversarial attacks, where humans try to understand how the algorithms make decisions and how they can fiddle around with it. So for instance, I think the example was given, I think a year ago with this Tesla self-driving, that if you would point like a laser onto the camera and it would distort a few pixels, that it would actually start making bad decisions. And this is ideally something actually typically that you would pick up with your monitoring system, and that would you hedge your risks by having good monitoring.
Okay, so in fact you can't understand AI, because sometimes when I use like social media, I start to think, how does the algorithm think?
Yes.
So is your answer no, you can't understand the algorithm, or just leave it there and try to use the big advantages, but don't try to understand like the specifics?
I think understanding the specifics is very important, and I also think specifically, but that's also my view on the social media algorithms. I think these algorithms already today, what type of information they feed us and how they decide which information to feed us, I think that is something that we need to understand, and we need to understand better, and we also should give the users better options for them to tweak and to maybe also potentially train the algorithm to suit their needs. So I would say that is really something we cannot say, oh, we won't be able to understand. I think we should obsess about trying to understand how these things work. And I think that is also something that is part of what we do is, yes, we start with performance, but as soon as the algorithm is not performant, the first thing we do is try and understand on a deeper level what is it that is going wrong, because if we don't understand it, we can also not fix it.
Let's look a little bit into the future. Do you think that algorithms and AI will be able to think for themselves in the future?
That's such an interesting question. What do you mean with thinking?
Like making decisions that can't be overruled. Like we are self-sufficient, we can decide, yes, I do it, or no, I don't. Do you think that could happen with AI?
I think in a way of how we think that we're fully conscious of making our own decisions, I think that can also be for AI, yes. Because I also think if you look at how we humans are all connected and how we make decisions based on the things that we've seen in the past and based on what other people have told us or based on the things that we've learned in our past experiences. We might think that we're fully
Autonomous, yeah.
Yes, exactly. And I think it's a little bit similar to how AI systems, what their highest level of consciousness might be in terms of decision making.
Okay, 3 young co-founders. You start a company that's taking risks. What is the main motivation of starting a company in economical challenging times?
Yeah, good question. Because when we started, we actually started fundraising right when COVID hit.
Oh God.
Yeah. So that indeed challenging times. I would say for us, it is we really started. We've experienced this problem ourselves, and it's a very, very big problem with a very, very big impact, and it's a problem that has to be solved, and we're just so obsessed with this problem and solving this problem that all of the rest and all of the risks associated with it and all of the chances of failure kind of are on the background. They're on the back burner. We're just the only thing we see is actually the goal, and we're completely blinded by it. And probably that is also a little bit naive, but I think that is also exactly that is exactly what you need to get there. Because if you think about all of the risks and if you think about all of the potential things that can go wrong and all the things that you have to do, you might not start in the first place.
That's really true. Now, how does your business model work? Because I know you're open source.
Yeah.
How many people or clients are using your products? How does it work?
So technically our business model is open core. And that means that there is an open source part indeed, and then there's also a paid part or a commercial product that uses the open source part. And the reason that we went open source is because we're building these algorithms to actually monitor other algorithms. Mm-hmm. So the people that need our algorithms, they kept telling us, we need to know how this is built, and to fully trust your algorithms, we need to understand them. And in order to understand them, you need to see how they are programmed. And that's why we decided to open source our algorithms, and that code and how it works and the logic behind it, that is just on the internet. Everybody can see that, everybody can download that. And then everybody can also completely freely use it on themselves. But then to make these algorithms work together in a coherent way, not just for one machine learning model, but for lots of machine learning models, there's lots of engineering to be done, and that is the type of engineering that we take care into our commercial offering. And then in our commercial product, we also have better iterations of the algorithms, better performance, more accurate, and that is kind of what then convinces our users that come into the open source and try it out and use it for one machine learning model, and then find it more important to have better monitoring algorithms that they then channel into our commercial product. How many users we have? At the moment, we're actually exploding. Our user growth this month compared to last month doubled, and we have at this moment 2,000 active instances of the open source that we know of. Because it's open source, people can then use this inside of their code base, but they can there's some like emission data that we sent of how the open source is being used, but they can turn that off. So when something really finds its way to production, it's probably being turned off. But right now there's 2,000 active instances globally around the world of very advanced AI teams that have operational AI making real decisions in the real world.
And how's the feedback?
Great. That is actually what keeps us going. Yeah. And that is also one of the main reasons why we decided to go open source, because data privacy, and if you have advanced AI teams and they have to procure a software, that takes a long time. And if the software is there and they can just take it, install it, and there's no data leaving their company, it can go way faster and we can get feedback faster. And it's this type of feedback that allowed us to iterate on our algorithms way faster, as opposed to going through an entire sales cycle that might take a very long time before then people can actually use it.
Okay, you have a real open mindset and it's problem solve driven. Now, you are a Belgian startup. I can imagine for young people to be an entrepreneur in Belgium with all the legislation and regulation, it's really hard. What's your stance on that?
That's true. It's very overwhelming, but I think it's just about getting started. And I think also for us, the way we kind of bypass, maybe I would call it, I want to call it pessimism, but it's more being the mindset of being realistic, is that we're very international and we have some Americanness inside of our company as well, where we see things very big, but then there's also some maybe some Belgianness inside of it that makes things rooted and that make things rooted in data and observations. And I think that is a combination that makes it very, very successful.
All right. Now, I want to move on to sustainability. That's a hot topic. How important is it for your business? Because I can imagine with all the data that is used in your company, you are using a lot of energy, for instance.
Yeah. One of the things that we actually try to solve with our product is to, I touched upon it earlier, is to do not the blindly retraining, but doing more targeted retraining only when it's necessary. And we can see that there for retraining costs, we've seen use cases where the training costs were reduced to 90%, they were reduced by 90%. So while still keeping the same performance. So that is, I would say, where we have our impact, our sustainable impact.
Okay, now how can society, with the help of companies like yours, ensure that the AI monitoring technologies are transparent, accountable, there is appropriate oversight to prevent misuse and abuse, and what regulatory frameworks are necessary to achieve this?
Yeah, so the first thing I would say to make the AI system transparent, and then is to actually install and have a monitoring solution, and to also properly map out the very risky use cases and the certain use cases that are touching lots of different parts in the business. And I would actually say that is something that is right now being covered in the EU AI Act. And the way I look at it is that actually, if you look at 15 years ago at the companies that were doing AI, it was mostly insurance companies and banks, and they have very, very large departments dedicated to the risk and the risk of these automated systems. But as AI and the technology becomes accessible to everyone, who don't have these risk departments, and by the way, it's not because of a risk department that nothing fails, because banking also failed, but at least there is some view on it and there is some risk mitigation being done, and I think that is also part of our goal and vision, that it is with a good monitoring solution that you can map out these risks better, and that we can bring this type of risk management not just to banks and insurance companies, but also to manufacturing, also to retail, and that it's accessible for everyone.
Okay, ambitions for the future?
I would say in the short term, it's our next funding round.
When is that?
That's a good question.
You don't know it yet.
No, it's like
fingers crossed.
We have at this moment we have so much traction, and we have so much momentum that probably will happen anytime soon.
Okay.
But funding and setting up a funding process is also a detraction, because that has to be run in our stage still by a founder, and inside of the company it's the founders that can move the needle. So if there's a founder focused on that, there's other parts of the business that we need to sacrifice for it. So long term, I see it, there's algorithms everywhere. There's algorithms in self-driving cars, there's algorithms that monitor our health, there's algorithms that are going to take us to Mars, and all of these algorithms, they need to be monitored. And I see the future where every single AI algorithm that makes real-world decisions is being monitored by Nanny ML.
Oh my God, so it all started with bits and bytes and it's ending with you, or you are the catalyst?
What do you mean by that exactly?
Well, you are the one that is in place now, so it all started a long time ago. I worked for a a company very long time ago, over 25 years ago, which started with computers and things like that. So I explained to customers, this is the digits and the bits and the bytes and everything. You have to use it, you have to understand it. And now we are moving on to some explanation that says to me that everything will be an algorithm. So will we monitor people completely? It will be part of our daily life as well, because it's a very small part now, but it will take over everything, do you think?
I think it's actually already a very, very big part. If you look at the information that we today consume, that is via an interface, via our phone, and that is already being controlled by algorithms. If you look at how much time people spend on their phone or looking and reading and watching, that's algorithms already. Also our cars, we're almost already there. In a few years, there's probably going to be robots wandering around in our household doing chores. That is also all algorithms, and yes, they need to be monitoring. And today, probably on the iWatch, there is a Apple Health where you can track and where you can gather certain metrics. That is also all algorithms that are processing this data for us. And as these algorithms become better and more powerful, they need to be more customized. They need to be specifically tailored to the individual, and if that is the case, then they can also make bad decisions because they're not trained well, and that is something that has to be prevented.
So your future is secured.
I hope so.
Thank you very much, Wiljan Cools, for joining me here today.
Thank you for having me.